Yes, students. Here, this is an easy question in which we have been asked to distinguish between conductors, semiconductors, and insulators, and we need to have two distinguishing features. So this is a very frequently asked questions in CBSE boards. So let's start off with doing a distinguishing between the three. So let's first talk about insulators. So on what ground should we talk? Let's the simplest one is conductivity. Let's talk in terms of conductivity. So if I say conductivity, so in terms of conductivity, we can say insulator is a bad conductor, or we can just say bad conductor. So I mean not possible, basically not possible in case of a perfect insulator. It is electrical conductivity is very bad. So this is electrical conductivity. So now let's talk about in a conductor obviously, because its name is conductor, so it has good electrical conductivity. So the reason behind that is it has free electrons, and basically the thing between that is the conduction band and the valence band are partially filled or overlap each other. So that makes it a really good conductor of electricity. Similarly, in semiconductors, it has moderate. They are moderately good. So we can just say it lies somewhere in between the insulator and the conductor. But it's not as bad as an insulator, but it's not as good as a conductor also. So similarly, like we have just discriminated the three on based on their electrical conductivity, let's talk about the resistivity now. Now this is something which is very interesting. If we talk about the resistivity, we will see that resistivity has a very good role to play in all three of them with respect to temperature. So we can say that the resistivity of an insulator remains constant at all temperatures, remains constant. Whereas in conductors, we know that superconductors are usually at very low temperatures. So we can say resistivity increases with increase in temperature. So this is something really nice, and exactly opposite happens in a semiconductor. In a semiconductor, we can easily say that it decreases with resistivity decreases with increase in temperature. That means if we increase the temperature, its resistance will become lesser. So and one thing that I would suggest in this question is always distinguish and then give examples also of each. So some good examples that we can give in terms of insulator are rubber, glass, porcelain, etc., etc. So you can give multiple examples for insulator. For conductor, a good example is say copper, Ag, silver, copper, silver, and aluminium. So Ag is silver, copper, and aluminium. Similarly, semiconductors, which are a few. So let me tell you some of them. One is silicon, one is germanium, boron. So these are some semiconductors. So we should always give examples also. So this kind of creates a good impression on your answer. So this will be the answer to our question. So it's a very frequently asked question in boards. So just keep this in mind that we have to distinguish them between their electrical conductivity and resistivity. And it's very interesting to know that how it varies with temperature and electrical conductivity, which is bad, good, and which is moderate. So that's the answer.